All right, on chapter 3, we only have a couple of sections that are, well, informative as well as maybe applicable for later use in your educational background. And that has to do with graphing and also solving. And so we're going to talk first about graphing linear inequalities. Now, linear implies lines, such as y equals mx plus b, where the exponents are 1 for both x and y. So we're going to start first with the idea of graphing with inequality symbols. So what will we be doing? Number one, we'll graph the linear equation and we'll talk about the methods in a minute. Equations, because it's more than one, it's like a system, with appropriate solid or dashed line. Then our second step is going to involve using a test point to prove which side of the linear equation should be shaded. To both lines. And then you'll see the area where the double shading occurs, meaning that is the solution, plural, possible for both equations. All right. Later on, we'll find the value of this shading and how it applies to optimization of production. But we're just now looking at it. So let's review the linear equation. It is y equals mx plus b form, identifies the slope, and that means rise over run, and the y-intercept, which is 0 and b, the starting point of graphing. So we can see that that works. Well, if we don't want to do y equals mx plus b for whatever reasons, then you can, second method, is to let x equal 0 for y-intercept. Then let y equal 0 for x-intercept. All right, and plot the points, and then graph. So you can see that either way helps you with the linear equation. The graphing approach is to understand the inequality symbols. All right, because this identifies where we shade and if it's greater or less than, and those conditions to the system of equations. So here we go. In this case, we can have this one greater than or equal to this symbol here, this bar under this symbol implies equal to. So this symbol reads greater than or equal to. All right. Then, of course, we have some more. Here we go. And this is, and we'll use the black, a solid line. Right. So now we're looking at less than or equal to, less than or equal to. And this symbol is also a solid line. All right, now we're going into the general inequalities. This is greater than only. So this is the dashed line. Because it doesn't include the values that we calculated. And this one is less than. And it is also a dashed line. So these inequalities will help us in understanding, first, if it's a solid line or a dashed line, and secondly, how to construct what we're trying to achieve. Okay, inequality symbols and graphing concerns. All right, once the equation is graphed, the test point. And if possible, we keep them small, like 0, 0, or 1, 1, or whatever, but it's small. When used in the inequality, and the outcome is true, then shade area where test point is located. Then you repeat the process for the second line. And the area will share is the solution area. All right. So there you have it. And of course, we have, in most cases, have some inconsistencies and other items. All right, so now we're ready. So here's our first example. Graph the inequality. Y is greater than or equal to x minus 8. All right. Well, here we notice that our m is 1 over 1, which means up 1 over 1 for the next point. Our slope is 0, negative 8. 0, negative 8. All right. Now remember, if you can't do it by your intuition here, we can use the x and y intercept. Let x equal 0, then y is negative 8. Let y equal 0, then x is 8. And this is a t-chart, and these are the two intercepts to make the line. All right, so we're going to plot 0, negative 8. There it is, right there. And then we're going to move up 1 over 1, 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 up 1 over. And we see that we get that x-intercept. Any way you want to do this is okay. We notice it's going to be a solid line. So we want to draw a line. So let me get them. And let's see, right about there. Oop, let me delete that. All right, let me do it again. Okay, just a second. Now mine isn't going to be real good. Well, I got not bad. All right. Oh yeah, that's not bad at all. So here's my line for that inequality. Now we're going to do a test point. Now we're going to do the test point. And our test point is going to be 0, 0. All right. So if our test point is 0, 0, then I'm going to put it in the equation. 0 for y is greater than or equal to 0 minus 8. 0 is greater than or equal to negative 8. And this is true. So we're going to shade that area where the point is. Now on the computer, you hit anywhere in the area of the solution, and it'll do it for you. Okay, and of course I'm doing it with my pencil, so I'm shading so you get the impression of what is expected. All right, so this is all solutions to the singular quality linear equation. All right. You're not asked to specify, you're just given a picture. Given a picture. Well, let's do another one and let's see where we are. All right. Here we go. In this one, we have 6x minus y is less than 9. Okay, a t-chart would probably be the best and easiest. So we're going to let x equal 0. That means, okay, if I have 6 times 0 minus y is less than 9, and all we need is equal to. We're not shading, we're just saying equal to. Then I have negative y has to be 9. So y is negative 9. All right. So we got that one. Now we're going to have y is 0. So 6x is less than 9. So x is 9 over 6, which is 3 halves. So it's 1.5. And it's positive. All right. So I have 1.5, which is about right there. And then I have negative 9 right there. I'm going to do uh, my line. That's pretty good. That's good. Now we notice that our test point is going to be something easy. So we're going to do 0, 0 again. So my test point is 0, 0. So remember my equation. Sorry about that. So we know it's a dashed line. And I need to come over here and let me get a smaller amount. And oops, still too big. That's better. And I'm going to make it a dashed line before I go any further. All right. So I have my dashed line because it's less than 9. And now I am putting 0 minus 0 is less than 9. And this is true, isn't it? Less than 9. So we're going to shade that part. Nothing difficult, just time consuming. Take your time. We're just getting a good handle of what solutions are possible. Um, and that's it. This is my solution possible. All right. So let's do, and I think, okay. Now what I'm going to do here, this one is going to be, because it didn't cover exactly, x equals 7. No, x is greater than 7. All right. And then we'll do the other one as x plus 2y is greater than or equal to -2. All right. So let's do this guy. Well, this says x has to be greater than 7. So what we're looking at is a vertical line, and it's dashed, of x equals 7. So if I was to do a t-chart, then x is always 7. So I can put 0 and 5, and I can plot those. And it's a dashed line. So let's look at those two ordered pairs. X is 7. So here is 7, and I have 7, 0, and 7, 5. And I'm going to draw my line. As carefully as I can. Now again, working with a pencil on a tablet is not always the best, but you can tell I try. Okay, we know it's had 7, and it's easier on the computer. Now we're doing the test point. So we graphed it. Now the test point. Oops, there it is. So in our test point, we're going to do, again, we're going to do 0, 0. And we have x is 0, is greater than 7, true or false? Is that true or false? No, it's not. So we would shade on this side. Of course, I would have to go back and make sure I have a dashed line. Sorry about that. But I do want to tell you everything correctly. All right. So here we go to our next one. And on this guy here, we're stating 2x plus 2y equals, is greater than or equal to -2. So we have a solid line. And we're going to use our x and y intercepts. X is 0, y is -1. Right? And then if uh, y is 0, then x equals -2. All right, so I have my two ordered pairs, 0 and -1. That's right there. And -2 and 0. All righty then. So now we're going to draw our line across. Let me get that. This one's always kind of hard for me, and trying to get them through the 2 points. Come on, come on. Post. I have to move it up a little bit and move this one down a little bit more down. Oh, too much. Oh, pretty close. There it is. Well, it's not close, but imagine it is. And we're going to do our test point as 0, 0. All right. So I have 0 plus 0 is greater than or equal to -2. And that is true. Therefore, we're shading on this side where the test point was proven to be true. Right. Okay. Now let's look at this one. And this one is y is less than or equal to 1. So this is a solid line. This one, y is always -1. So I can put 0 and I can put 3. There you go. All right. So we're going to graph them. 0, -1, that's that one. And then 3 and -1. And I'm going to draw my line. All right, good enough. And I'm going to do a test point. And again, our test point is going to be 0, 0. And 0, if I put in for y, 0 is less than or equal to -1. And that is true. Oh, it's false. Sorry about that. I see that's false. Sorry. 0 is not less than -1. It is greater than. I am so sorry. I hurried. That's what it was. So I'm going to shade right here. The 0, 0 did not work. It was false. So the answers are below. All right. So now we're coming into our 2 that we talked about. And let's see what happens here. Graph the feasible region for the following system of inequalities. Tell whether the region is bounded or unbounded. Bounded or unbounded. So let's look at that. Bounded would mean it's specific, unbounded, it's infinite. All right. So we're saying first, x plus y is less than or equal to 4. So we're talking a solid line, and we're talking a x and y. If x is 0, y is 4. If y is 0, then x is 4. So let's plot those. 0 and 4, and 4 and 0. I'm going to draw our line, and it's solid. See, I'm following my line here. Hold on. Right here. All right. So this is my solid line for x plus y is less than or equal to 4. And we're going to do a test point of 0, 0. All right. So 0 is less than or equal to 4 is true. So we're going to shade that. All right. So now we're going to do the other one. On the other one, I have x minus y is greater than or equal to 6. So in our t-chart, x and y, if x is 0, y is negative 6. If y is 0, then x is 6. All right. So here we're using the blue. 0, negative 6 down here. And 6, 0 there. All right. So I'm going to draw my line. All right. Pretty good. Now that's my x minus y greater than or equal to 6. All right. So then we're testing point. We're doing a test point. And our test point, I'll use green this time. Our test point is, and we got to do something somewhere. So we're going to make it, let's make it, what is that? 5 and 1. All right. Make it interesting, right? And we'll do it that one. 5 minus 1 is greater than or equal to 6. This is 4 is greater than or equal to 6 is false. Therefore, we're shading underneath. So let's do the pink. So we're doing underneath that line, and we want to see where they overlap. And they only overlap in this contained area here. But it's unbounded because it's got many. Well, actually, it might be bounded. So there you have it. And we see what the answer is. And you only had I think you only have 2 of those. I want to thank you for listening.